Welcome to the Women Who Go meetup. You don't have to be a woman to be here because that is exclusionary and we're inclusive. We just want to help people learn Go and use Go and love Go as much as I love Go, which is sometimes too much. We're part of Forge Utah. If you're not aware what that is, it's a nonprofit that we have here in Utah with the purpose of orchestrating educational experiences for, as our president Clint says, for the technologists. So basically, anyone who has any cool interest can come learn things. And here in the Women Who Go meetup, we tend to focus on the more new to Go topics. We do have a Utah Go user group, and they tend to hit the more, no, I don't want to say advanced, but definitely niche, right? Not as many general broad applications. A little bit, you do have to have a little bit of Go experience to be there and follow everything, but not to participate. Like, I don't want to discourage anyone from going to that meetup too. It just has a different base. But yeah, we have a Slack you can join. The link for that is on the meetup page, and I can also throw that in the chat here in case anyone wants to join our Slack, where we have riveting discussions about all things Kubernetes and occasionally a couple other things. That's my running joke, is we talk a lot about Kubernetes and not much else. But we have great resources on there. Basically, if you have any question, there's somebody there that can answer it for any topic whatsoever, and we have a super broad base. I don't have a whole lot of comment announcements broader than that. Besides we did have a scheduled, a conference scheduled. The Go West conference was originally scheduled for 2 weeks from now, May 7th and 8th. That it has officially moved. I'm still working with Jordan Commons to get a new date because the person that I was working with no longer works there, so it's been a little bit of a mess, but hopefully we're trying to get a date in October, November, and we will be following all of the appropriate CDC distancing and sanitation guidelines to provide the best experience when that time comes. But since we cannot provide the appropriate in-person experience now, we will provide a virtual experience courtesy of Google Meet as provided to us by Forge Utah. I feel like I just read that. That was all from my head. Anyway, so I'm going to turn the time over to Justin. He is a great, wonderful Go veteran. He's helped us quite a few times as we've done workshops and other intro to Go things. And he's going to be talking about all things database and how to integrate that with your Go programs. If you have any questions and you don't want to just yell at him, feel free to put them in the chat and I will yell at him for you. Other than that, feel free to just make comments and keep this pretty casual as we go along. I don't want to lose that the organic conversations that we go as we go along. So it's all your time now. Justin, feel free to go ahead and start.
Cool. Like she said, my name is Justin Rhodes. I use Go in my personal time, and yeah, let's jump. So who I am. I started my career as a Java automation tester for Sinclair Oil. After about 6 months, I moved into development, and currently I'm the sole Salesforce developer for Sinclair Oil for the last 4 years. I enjoy learning new languages and technologies. Currently, I've been digging into the View Composition API, which has been fantastic to play with. And obviously, Go. Some other fun facts. I've done 3D art in the past and a huge D&D nerd. Like she said, we're going to be talking about databases. And to start that off, we're going to talk about what we're going to talk about. And in that regards, we are going to talk about the tip of the iceberg, right? There's a lot of things that people can do daily with databases that we're not going to cover. And there's a lot more that I have no idea how it works. So kind of set your expectations accordingly, where we're just going to talk about the surface stuff. With that,
I was going to say, Justin, if we have any questions that you can't answer, we'll defer them to Anthony, as he is my boss, and therefore he knows all of the answers to everything.
Sounds good.
I'll defer back to Mariah, and then she can defer back to Justin.
And I will defer to Google, and we shall Google search. Probably not. But there's two primary camps of databases. We have SQL, which stands for Simple Query Language, and relational databases. And then we have NoSQL, which comes in many different flavors. This document-oriented database, which is just JSON files. There's key value pairing like Redis and other methods. How many here have dealt with SQL before?
I have.
Let's go with half.
Half?
Well, actually, you should say, who hasn't written a SQL query before? That's the better question.
Okay, let's go with that question then. Who hasn't written a SQL query before?
I've done just a little bit, but yeah, just a little bit.
Cool. So for those of you who haven't done anything in SQL before, SQL is like working with a spreadsheet. You have rows and columns. The columns represent the data structure of a table, right? So the spreadsheet is a table. Your columns are the data structure of that. And the rows are the unique records that fit that data structure. So the spreadsheet we have up on screen right now is one I found on Kaggle. It's the first 10 minutes of a League of Legends match. Multiple matches here, right? So each game is a row, and then the columns are the details on that game. So some of the basic SQL queries that we will be using daily are CRUD operations, right? Create, read, update, delete. The create is not there because we'll look at it later. It's long, it's nasty. The read, however, is pretty simple. You start with a select keyword, and the asterisk in this statement stands for all columns. If you wanted a specific column, you would type in the name of that column. And the select statement would only pull that column from the tables. So let's go over here to my DataGrip. And if I run this method, we get all the columns. I come over here and switch that asterisk out for just blue wins and run this statement again, you only get that one column. So let's go ahead and set that back. We're going to look at the next statement. The next statement is update. So update does what it says. It updates data in the database. Keyword update, and then you specify the table name instead of the field name. You will update the table and set the field name. So in this regards, we are updating the blue wins field to 1. Now, the important thing about an update and a delete statement, which you see right below, is if you don't specify a where statement to this, you will update or delete all records in your table. Right? So if we come back down here.
Have you done that, Justin? Have you not put a where and wiped out your database by replacing all of the values?
I have done it on purpose. I have yet to do it on accident. I have an instance at work where I clear a table before I insert all new records instead of doing a update on those records, just because some of the data may not exist anymore. So there is a use case where you want to delete all records.
Cool. I was just checking.
I did not learn that one the hard way. So let's go ahead and take this here, pop that in there like such, and we'll run this update. You see the green check mark means the SQL statement worked. There's no errors, but we didn't see anything change here because we need to go and select them all again. And they come in a different order. Of course they do. So let's do a where statement on the game ID that equals that record. So if we query that, we get a single row of all the columns, and we can see that the blue wins has been updated to 1. We can update that back to 0, and then run this query again, and we see it's now 0. So navigating a database is going to be a lot of these. Select this, where this is going on, especially when you're looking for a specific record of some sort or group of records, right? Because one of the things we can do here is where blue wins equals 1. Now we have all the records where the blue team won the match. So that's the update and a little bit more on the read. Delete is similar. The only difference is we do have to use the keyword from. From is used to specify a table. I don't know why update doesn't need that, but delete does, or at least in Postgres. And then again, where statement, because you don't want to accidentally lose all your data. There is no Control-Z with databases. Unless you make a backup daily. Then kind of, but for the most part, yeah, no. So with that said, let's go ahead and jump into Go and see how does that look in Go. So here's a very basic Go file with some simple SQL statements to kind of show, and we're going to interact with the same data as before. First thing we need to do is get our imports. So the Golang standard library comes with this database SQL. This is going to be the main thing that we use to interact with the database because it contains the open method, and that gives us the database object, which then contains the query statement and other things. We'll also need a driver. So what the driver does is this is a way for the database or for Go to know what database it's talking to. Your databases come in many flavors. There's Postgres, MySQL, Oracle, and I think it's Microsoft SQL Server is what it's called. Not sure what that one's called exactly. But each one of them has their own flavor of text. Majority of them keeps the same standards that we're talking about, but there could be oddities among them. So getting into the code, we'll see that I need to specify the, well, sorry, let me start at the beginning. We first grab the SQL that we imported. The open method opens a connection to the database. This takes two arguments. First one being what's the flavor of database we're using. And in this case, it's Postgres. And then this connection string. This connection string can be made in multiple ways. And later, I'll show you a different way to create a connection string. In this instance, I have a constant or a constant variable that contains a text that looks something like this. And in typical Go fashion, we make sure the error is nil. If it isn't, we're going to log fatal, and then we're going to move on with our day and keep that DB, which we can now use down here to start making queries. So this first example is how we would get data out of the database in a read function, right? So what we're doing is this. And it's the where statement. We are getting a list of every single one of these game IDs. We're checking if that query was successful. If not, it would throw an error. Otherwise, we would get these rows. Now, these rows are not strings. These are returned as, I can't remember off the top of my head. These are returned as
slices of bytes are wrapped in the row object.
That. Thank you. So we got slices of bytes wrapped in a rows object. So instead of doing this fun little bit of code where we would need to run a method called scan, which is part of the rows object, and scan the ID into a variable, we're just going to quickly get a count. So I set up an all right, my brain just went blank on what this is called, an iterator. And we're just going to iterate it up. Incrementer. There we go. And then I have a print down here to print that value. We'll see what our total row count is. We should be expecting around 10,000 rows. And it's 9,880 rows there. Come over here. You can drag this all the way down. Oh, it caps at 500 apparently. So let's grab another fun trick.
Okay.
Count function. So 9,880. So that's what we are expecting. Any questions so far on how that works?
No, that makes sense.
Cool. So the update method is the same as we saw before. The only difference here is we're doing what's called a prepared statement. So what a prepared statement is you create your statement and then you can execute it at a later date. So in this case, we can also provide some arguments, right? We don't know what game ID we need to use. So we make it into an argument, and using this variable syntax of $1 says the first argument goes here. So if I had multiple arguments across my statement, I would do $ and then specify which argument it is. 1, 2, 3, so on and so forth. When we're ready to execute the statement, we grab the statement object we get back from the prepare, and then we run execute and then provide the arguments. So in this case, I'm providing the argument of a specific record, and then we would see that record get updated. We would then take the results, grab the rows affected, and get a count on how many rows were changed. And as you can see down here in my logs, we changed 1 row. You would do the same thing for a delete. I just have it commented out so I don't accidentally delete something that I don't want to delete, but it's a prepared statement as well. So we would prepare it, and then when we execute it, we would provide in this case, the game ID we want to delete. We could also delete all records with a single value. So going back to that blue wins scenario, if I wanted to, I could delete all records of the blue wins, be it all the ones where they did win or all the ones where they didn't win. And we would do the same thing as the update, but the only difference, we would change that to blue wins. And then when we provided the argument, we would provide which one we want to delete. So, and then the one that's really nasty, the insert statement or the create statement. This is where we're going to create a record into the database or into that table. And the formula here is insert into table name and then provide every column you want to provide data for. Then you'd use the keyword values, and you would have to provide the values in the same order as the column names. If you don't do the same order, your values are going to get mixed. So as you see here, we have that insert into right there. Then we specify the table, and then we got the first 14 columns in that table. There are more columns. And then we provide the argument variables. And all the way at the end here, we then provide all the arguments. So you have to keep order 3 times, well, mostly just 2, to make sure you get this is a disaster. This is a very painful process. And I have a database at work that has over 150 columns. So if I wanted to create a unique record for that, I would be typing for a long time to make sure I got everything in the right order. And if anything ever changed in the middle of that, I would just probably rewrite the whole thing to make it easier so I don't keep making bugs. But,
hey, Justin.
What was that?
Hey, I was curious if you've seen anything in Go or even any other language, I guess, that helps you with creating some of these statements, something that's like maybe like agnostic of what type of database.
We haven't gotten to the ORM yet, Anthony.
Oh, is that coming? Okay, all right. I'll just be quiet.
You're good. No, that's a perfectly valid question, especially after just seeing that one line of code. But let's go ahead and get to that. Before we get to that, though, there is one other thing I want to talk about with SQL in general, and that's the relational part. So one of the big things with SQL databases, and one of the nice things, is you can relate multiple tables together to get a bigger picture of something. In this slide, you see that I have 4 tables. I have a players, I have a characters, I have a games, and I have a player session. So the players table would contain all the information for that user, right? The username, when were they created, how long have they been a player, so on and so forth. Then we have the characters, which contains specific information to the characters in the game. And then we have the games. And you can think of this one as the table we saw before, where we were looking at the big picture, right? How did Team Blue do? How did Team Red do? What's the big picture? Well, we can provide the IDs for all 3 of these fields into another table, which gives us access to that information through what's called a join. What a join does is it takes that row from one table, and if it has a matching field, it takes all those columns and add them to the end of the table you're joining to, right? So in this instance, we have the player session table, which then gets players added to the end of the players session table. Then the characters information gets added to the end of the players table, and then the games. So you can get a very massive amount of data with these joins, and it's very useful because if you look, if you take a big picture of what this represents, this shows you how the player did in the match that we saw in the games. So we can see individual player information per game. But that's a kind of a bigger subject in SQL and how these joins work together, because you got outer joins, inner joins, all sorts of things.
Yeah, I have a question on that.
What's up?
So is there a good way to practice writing queries? I know a lot of times there's not like a massive amount of data that you just have to play with. Do you have any recommendations or no?
You can go mess around with big
I recommend doing what I did for this presentation.
Yeah, what did you do to get just a database that you can just practice with these joins and queries?
I went to Kaggle and grabbed a data set from that.
Okay, perfect.
And then copied that CSV file into a database.
Oh, okay.
So
there's a huge
one way
CSV file
you
put it in.
Olivia, you can do that in BigQuery as well for free.
Okay.
With their public data sets. I'll post a link in the chat. But
Perfect.
it is, I will to advocate for Justin's point. If you can get it into a SQL editor on your computer though, there's just a certain amount of comfort that comes from doing it on your computer as opposed to doing it on Google's platform. So
yeah. Okay.
Mm-hmm.
And I'd add to that as well that DataGrip, this SQL-based IDE sort of thing that he's using in his presentation, is really good for syntax, kind of like the intelligent syntax that you get popping up when you're writing code. It has that same thing for SQL, and it'll help you kind of figure out what is available on your database in real time if you have it connected into the editor.
Yeah, what editor is this, Justin?
This is DataGrip, like he said.
DataGrip, okay.
Yep, this is one of the JetBrains ones. There's also DB Visualize, I think it's called, which also has this ability to showcase field names and stuff like that. But depending on go ahead.
There's one more that's also made by, I believe it's made by Microsoft, that follows the same formatting as Visual Studio Code. If you like that format, it does the same sort of thing.
Gotcha. Yeah, so I would recommend do some research on a database IDE like DataGrip, because this just makes your life easier. because you can access the database via command lines and other tools, but if you're really going to play with data, you want something like this. So nice.
Yeah, I like that.
So let's see here. And practicing joins is also a great idea, because one of the problems with joins is if you don't specify all the possible fields that are related together, you will get multiple records in a join. And what I mean by that is if I said join players and I didn't specify an ID, or I specified a bad value, I would get a new record for each unique player on a certain join. I don't have a good data set here to really show that. So sorry. If I find something, I'll shoot it over to you.
No, that's good.
But with all that said, let's go ahead and jump into Gorm. So Gorm is one of the ORMs that you can get for Golang. What's an ORM? An ORM handles the tedious basic SQL statements constructions behind the scenes. So you talk to it in the language you're working in. And it reduces the amount of code you have to write. It also makes it so you're not speaking SQL anymore. You're speaking the language you're working in. In our case, it's Go. One of the things Gorm does is it uses your structs. So if you've done a lot of things with Go, you know structs are how you kind of format your data. And Gorm takes advantage of that and uses the struct to associate fields to your table columns. You can also provide tags at the end of your fields to provide additional database-specific information. So in this example right here, my email can only be a size 50, which means it can only contain 50 characters. My password, though, can contain 255. The avatar URL can contain 255, so on and so forth. But Gorm uses the type of data and the name to figure out what column are you talking about in your database. And then you can write code like this, which, look at that create statement. There's no insert and there's no massive amount of columns to take care of. You pass it a variable containing the type you want the data to go into. So in this case, I'm going to pass it a variable called character, which is of type character, which matches the table, the characters table. And it does the insert statement for me. I can find all the players by giving it the type of an array of players, or I think it's slice of players. Update is a save statement where it will focus on the ID on the variable you hand it. So if you grabbed a player from the table, ideally your player has an ID. And when it updates, it'll do a where statement on that ID so that it can make sure it updates the correct player. Same thing for delete. So it tries its best to help you not accidentally dump an entire table or update an entire table with information that was not needed. But that's the basics of Gorm, so let's go look at it live. So let me go ahead and just switch my directory over to Gorm. So with Gorm, We have the same number of imports we have to do. The difference is Gorm has everything internally. You just need to import the dialect or the flavor of database you're working with. And again, we're working with Postgres. Gorm also provides this nifty little thing called a model. And what the model does is it contains generic fields. In this case, it will provide an ID field, a created at, an updated at, and a deleted at field. And you can just pop that in and let that run. You can also make a custom model that will work with Gorm, but handle things a little differently. And we'll talk about that in a little bit. But for right now, you'll see that I'm not worried about it. Gorm open, same thing as SQL open, dialect, and then that connection string. And then we get a DB like we did before. One of the things Gorm recommends is this defer close. So all this does is when the code ends, it will then close the database connection because you don't want to just keep connecting and increase that connection pool. Something I'm not super familiar with, so that's as far as I go with that one. The other nice thing with Gorm is considered a code first ORM. And what that means is Gorm can actually go create the tables for you. And that's what this auto migrate does. You give it the, I don't know what to call these exactly, but you give it the type of the struct you want to work with, and it will go to your database through the open connection and create that table for you. So in this case, I have it auto migrating the player table, which will be based on this information here, and the character table, which will be based on this information here. Gorm also does this thing called .error. So if I didn't care if it errored out, I can just not do .error. But anytime I do this .error, I'm going to get an error to check for. Best practice, always do the .error. But you don't need to. So before I run this code, I want you all to see that this database currently does not contain a player or a characters table in this public schema. But when I run this code with my go run main, don't worry about the error. That's, for some reason, I haven't figured that out yet. But what I do know is it worked. So if I go refresh, we now have 3 tables here. We got characters and we got players. We also have data in that, but we'll look at that in a minute. So yeah, we'll just keep this up so we can showcase things. So if we go down here, let's go ahead and run that create statement that we saw in the slides. And notice there's no massively long piece of text. I just created a character here like I would create any kind of data type in Go, slap that onto a variable, and then push that variable into the create method or function. I checked if the function errored out. If it did, it would have logged a fatal, did not log a fatal on this one. And we got a character created. We can do something else too, is we don't have to necessarily dump the data into a variable. We can create the data right within the function. So that's what I'm doing on this one. I'm just creating the player right there in the create function. and it'll create the player as well. The next thing we'll go do is we'll go read. So I'm going to create an empty player variable of the first player. And so in this case, Goofy Bob was our first player. Hey, look, I named our player Goofy Bob. We can then go down here and we can create another character real quick called Beth. I think this is where it errored out. Because on that first statement, you can provide arguments, and these are your where arguments. And it should be focused on the ID. But judging from my logs, does not look like that one worked at this time. Shiza. All right. Yeah, we'll just showcase better ways to do these where statements, because we got this one which did work, and this is generally how you'll do your where. You'll start the function where, and then you'll provide the arguments. So the query and the arguments. That's the same thing as here in the database. Is we would declare the method, and then I would provide an argument like this. The only difference is this would be a question mark instead of the normal syntax. Question marks are used for the Gorm piece. That's the special case it's looking for to insert a variable. Then we would give a comma, and then we would provide the value we wanted to be inserted into that question mark. Now, if I had multiple question marks, it would just go in order of operations. So first argument goes to the first question mark, second one, so on and so forth. And then our update statement works, or should have worked. Looks like it didn't. Oh no, I don't have it displaying anything. Oops, forgot to read it again. So the update method works by you change the data on the variable you're working with, you pass the variable into a save statement, and it would save. So in this case, if I did a DB, and you can see all the functions that this comes with. There's a lot of things you can do that we're not getting into. You can do your prepared statements. You can do your, I think you can do joins. I don't remember off the top of my head. I'll have to look. Pass it an ID. We'll equal that to that. I know Bob should be 1. If I'm ever curious, I could come down here to my IDE. Let's start from players. Check out my IDE here. I do have Beth. I guess I just never read it. All right, let's go grab Beth. And then we can go and scan that into a player. And just to make sure I grab a new one, we'll do player 2. We'll equal that to the player data type there. And that way we'll pass player 2 in. So I apologize. Go grab Bob again. We'll grab Beth as well. Just make sure we have Beth. And log.println layer 2. Now, let's see what happens when I run it. I get awesome Bob, but I don't get anything else. It's like I got, anyways. Don't worry about that later. Live coding rarely works. Our delete statement is much like the update, where we just plug in the value we want to delete. It'll take the ID and it should go delete it. In our case, I don't think that happened. Oh, hey, created Beth again. And an awesome Bob. Awesome. Alrighty. So one of the things with the delete statement in Gorm that I want to kind of point out is notice this delete at. Gorm by default does a soft delete. And what that means is it'll go place a timestamp in this deleted at, and then if any value has a deleted at, it will not go grab that value. So that is why Awesome Bob was not pulled either time. That makes more sense. If I wanted to permanently delete the record, I would have to use this unscoped method, which removes some of the underlying functionality Gorm does for you. Mainly in this case, it will remove that deleted at, that soft delete function. It'll just go and straight up remove that. Any questions on Gorm?
Justin, I have one.
Okay.
I think hopefully this will kind of help Anthony in his thought processes. I'm trying to read your mind, Anthony. In your personal opinion, Justin, when is it better to use a SQL client, such as just the Golang SQL, to do SQL structs as opposed to using Gorm? Like, do you have a preference or a use case explanation?
The use case would be depending on how complex of a SQL state or how complex the data from the database you need. So in the case of, say, this, where we have a bunch of joins going on, we have a where state, and we're not going to grab all the data from all these tables. You know, we could say we need to select a few fields from player, a few fields from character, and a few fields from the player session, right? That would be a use case where you would probably have an easier time using the SQL, the raw SQL stuff than Gorm. Though, with that said, too far. Gorm does come with the ability to run raw SQL. So let's see here. I think it's this execute function. Yeah. So this execute function will run raw SQL. You would do the entire statement in this execute function, provide the values, and run it as kind of a hybrid between what we saw with just the driver and the SQL library and Gorm. So for example, I would still be able to do this .error or a .scan to place that information into a data type that matches. So I do not believe Gorm is smart enough that you provide it a complex data structure to know to grab that information from multiple tables. I've not seen that used that way. So that is a use case where you would want to do raw SQL.
So that answers my question. Sorry to
Cool.
try and read your mind, Anthony, but I was trying to help from your previous question.
Cool, thanks. Yeah, I guess just to speak from a little bit of experience, in the past, there's times when it's like, if you're doing like an inner select or something, where like it might be pretty difficult to do with an ORM. I don't know, just situations like that where it's like, maybe there's a performance consideration that needs to be made, and it's just easier to do it in raw SQL than try and jump through the hoops of the ORM. But
for sure. No, it's definitely, ORMs help you with the basic stuff. The more complex your SQL statements get, the more likely you're going to just kind of start inherent or doing SQL for everything. Anybody else?
I have a related question to that.
Yeah.
So I generally don't use an ORM, and I won't get into the reasons for that. But in working with the Go SQL, it doesn't have a way that I've found to convert it into a struct, to deserialize into that struct. In most languages I've worked with, I usually wrap that still without the ORM, but I can get that functionality out of it. I haven't found a way to do that in Go without installing something that's more heavy-handed than I feel like I need, like Gorm. Do you have any recommendations for that?
I think your best option is there is nothing you can do. As far as I've read the last week or so, there's no way to dump the data directly into a struct just with the drivers. But there is a library called SQLX, which
I put the link to SQLX in the chat.
Cool. I think SQLX is the lightest you're going to get that kind of functionality.
Yeah, thank you.
Yep.
It just seems like without generics, which I won't get into that debate, but I'm used to working with either generics or duck typing, and it's pretty simple for me to write it myself. Without that generics, it's been difficult. So maybe SQLX is what I'm looking for.
Yeah. Hopefully that does work for you, because I feel bad if you have to do each individual thing.
We use SQLX a lot, and we have a couple of things that we deploy to customers' servers. So we're very, very picky about the kind of dependencies that we put in there. And SQLX is so helpful that we use that. We're willing to take on that dependency. You can do scan right to a struct, and we've actually rewritten a lot of our code to incorporate that. So it's been really helpful.
Awesome. Thank you.
Cool. Is there anything else?
I just wanted to welcome Carson for joining.
Thanks. Yeah, sorry it took me so long. Had some other stuff going on earlier.
All good. All right. So one thing I wanted to kind of showcase is all of this is nice, but this is all very, very bare bones in a single file. So, kind of getting a more real world example, show you my personal project, at least the database side of things. So first thing I want to kind of showcase is this is doing a few things here. Let's see. So first, we're doing the same thing we did before, where we are importing Gorm, and then we're also importing the Postgres driver. We're then making the DB a package-wide variable, so that anywhere in my database, I can grab this DB. And then the next thing I'm doing is I'm making a custom base model. Gorm uses just incrementing ID. So if we go down here, you can see I got 1, 2, 3, 4. It's just going to increment the ID. My use case, I wanted a unique ID. So I grabbed the UUID library and I notified Gorm that it is a primary key. I also wanted the created at, updated at, and deleted at. I had to rebuild those because I'm not going to use the Gorm's model. I'm going to use this one instead. So I had to do a little bit of tweaking with the tags and the data types to match how Gorm handles things. But this base model Gorm will interact with this base model the same as it would for its own base model. And it does that via this before create function. So the other thing it does is that's where it creates the unique ID. So anytime I run a create function, it will run this before create and give me the unique ID instead of the incrementing ID. And then, as I said earlier, another way to create that connection string is you specify the types of data you need. So the user, the password, the host, the port, and the database that you're interacting with. I'm also using a hosted solution, so I have to specify the SSL is required. I then go get that information from the environment variables, and then I plug that connection string in. So a little different style of connection string, but it still works. So this config file just handles getting all the base information taken care of, connecting to the database, creating that base model so that I can use it everywhere. Now on a actual table, we go in here and we showcase what I showed in the slides where we can specify sizes. We take that base model and put it right at top. So we now get our ID, our created at, updated at, and deleted at. The other thing I recommend is learning interfaces. So nice thing about interfaces is then when you start doing unit testing, you can bypass actually inserting data into your database and just create a interface so that you can fake those inserts. Then when you actually have to test the database stuff, you can do that manually or using the I think it was called integrated testing. There's a special flag you can put at the top of tests to run them only when you provide a certain flag on the test call. I can't remember off the top of my head. So the way these methods are built are to utilize Gorm, wrap them up, and then give me more functionality. So for example, this create, I have this .scan, which will give me back from the database. So when it gets inserted, that ID is created, and now I need to capture that ID. So I use this .scan method to pull data that I just created out of the database and back into the variable I had. So that's something you would do a lot, is just scanning data back in and then passing it around. Another thing that we didn't really talk about, but that you will do is this .in, or sorry, not .in, this in keyword in SQL. So coming over here, the in keyword does the following. If I grab the ID and I said in, I can then provide an array of possible IDs. So let's say I want 2 and 4. This in keyword gives you the ability to say, hey, I need something across multiple values. In this case, multiple IDs. In my use case, I got these things called feature IDs. So I have what's called a link table, which is where I provide an ID for one table and an ID for another table, and this is where they link. You mostly do this when you have a many-to-many relationship. Trying to think if I have a good example of that. So let's say we wanted to build a table that contains all the characters a player plays. We would have a table that takes the ID of players and the ID of characters and just makes a record with just those 2 IDs. That's all it needs. Then to get what those IDs actually mean, we would use the join statement here, right? And we would select this made-up table called player_character, and then we would join players on the player ID and the characters on the character ID. So much like I have here, but we're using this link table as the base table to interact with. We then have access to all the players and the characters they've played. Now in my where statement, I can say, hey, I just want player A. Now I can see what every character player A has played. Or I can check on the character and see every player that has played a certain character. So link tables are very bare bone tables that allow you to associate a many-to-many relationship, because you can have multiple players play multiple characters and vice versa. So in a use case like that, I'm getting data from a table where these NPC features are. So I'm going into that link table. I'm saying, here is the NPC ID. It's giving me all the links. And then I'm taking those links, putting them into a slice of UUIDs, and then providing that slice in this in statement. Features that this NPC had. So a little bit more chaotic. You could do one of the things you could have done is you could have done raw SQL and do all the joins that we talked about earlier and just get the data you wanted. Or you can break it down into steps like I did here. Performance may vary, and there's use cases for both. But if you want to do everything in Go, you could do it in this way. But yeah, I think with that, that's all I got. So if you have any questions, please don't hesitate to contact me. You can find me on the Slack channel under Justin Rhodes. I'm getting back into Twitter, so you can find me at BFG Coding. You can find me on LinkedIn. We can chat however you guys want. My email. And then best place to reach me is Discord. That's where I spend a lot of time. So with that, that's all I got.
Thank you.
Yeah, I was trying to see how we could do a virtual clap. I really miss the claps at the end, because that's how I would edit my my videos, was with that clap. Anyway, thanks, Justin. That was awesome. Do we have any questions for Justin in the immediate? Cool beans. Anyway, thank you again. That was really awesome. I haven't looked that much into Gorm, but that was really cool. I really enjoyed that demo. Yeah, I want to thank you all for coming. I'm gonna leave this Zoom call open, but stop recording.